All right. Hello, welcome back to another lesson of distance learning with good old Miss Lee. So, we are moving on to the next section. You will want a calculator today, so go ahead and grab that if you don't have one. And today we are going to continue with law of sines. So the method that we're using to solve these triangles is not different. There's just one extra thing to check for, but the solving part itself is very, very similar. So this part up here is meant to be a little warm up. So we're going to let B be an angle between 0 degrees and 180 degrees. If sine of b equals 1/2, b equals blank or blank. So there are two possibilities. I'm going to use my unit circle. You don't need to grab yours. So again, we're looking at sine here. We want an angle b. We're talking about degrees now because that's more natural for triangles versus radians. So where does sine equal 1/2? Here and here. And notice that is at 30 degrees and 150 degrees. So there will always be two options when we're looking at between 0 and 180 degrees. There are always going to be two angles where sine equals 1/2. There will always be two angles where sine equals root 2 over 2. There will always be two angles where sine equals root 3 over 2. So I want you to notice something special about these pairs of angles, 30 degrees and 150 degrees. Those add up to 180. What about 45 and 135? Those add up to 180. 60 and 120, those add up to 180. So the pairs that you get will always add up to 180 degrees. So here we use the unit circle for that one. Using unit circle, and we got that B is 30 degrees and 150 degrees. And of course, there are infinitely many more, but we were only looking at between 0 and 180. The reason I want to focus on those today is because those are the only angles that you'd be working with in a triangle, right? You can't have an angle of more than 180 degrees in a triangle. So that's why we are focusing there. So we noted these add to 180 degrees, which is called supplementary angles. So those two angles will always be supplementary for sine. So if I want to do this problem, I cannot use the same method of using my unit circle, which means that I have to use a calculator because we don't have 0.4 on the unit circle. So need calculator. So in order to do this on the calculator, to find an angle, right, you can't type this whole equation in. You're going to instead type in that B equals inverse sine of 0.4. So that's what you type into the calculator to get the angle. So I'm going to do that now. But remember, inverse sine was restricted. So when you type this into the calculator, it's only going to give you one angle because it's only working over here. So it's not going to pop out an angle that's over here. So it's giving you one of the two possibilities. So let's round this to 23.6 degrees. Right? But there is another angle that sine of b equals 0.44, okay? This is inverse sine when we typed it in, so it's only giving you one answer, but there are multiple answers. There are two between 0 and 180. So to find the other one, you just need to find the angle that is supplementary to this one. So to find this one, you have to do 180 minus 23.6 degrees. So when I do this, you guys, I like to just do 180 minus, and then I hit second, and then the little negative down here, and it'll look like that, and it'll subtract your previous answer. I'm getting 156.4, or you could have probably done that in your head. So there are two possible angles. And then for something like this one, if you remember the range of the function sine, it's -1 to 1. So this is never going to happen. Here there's no solution. That's because the range of sine is -1 to 1. If you type into your calculator inverse sine of 1.2, let's say you forget and you type it in, you'll get domain error. That's happening for a reason. It's because 1.2 is not in the domain of inverse sine. So no solution if this number is bigger than 1 or less than -1. So now we're going to use this to solve some more triangles. So today we're looking at the SSA case, which just means that you're given side, side, and then an angle. And that's referred to as the ambiguous case. And the reason that it's called the ambiguous case is because the given information can either give you 0, 1, or 2 solutions. So there are 0, 1, or 2 possible triangles that will result when you are given this information. So we will go through one example of each. We're going to start with one solution. I'm going to draw out the triangle just, I don't know, I think it's nice to kind of have a visual. Again, these are not drawn to scale. So this is A, B, C. A is 35 degrees, side A is 5, and side B is 3. So notice here we have angle, side, side in that order, or side, side, angle. So when you're in this situation is the ambiguous case, and notice it spells out, if you write it the other direction, ASS. That's the ambiguous case. So step 1 here is going to be, let's fill this in as well. Measure angle A, 35, and we have A, so we can use law of sines because we have both of those. Side B is 3. We don't know angle B, so that's going to be step 1, find angle B. Right now there's nothing we can do with C. Find measure of angle B is step 1. So we're going to use law of sines just like we did last week, but now we're solving for an angle instead of a side. Okay, so we're going to have sine of 35 degrees over 5 equals sine of B over 3. I will multiply both sides by 3, and I'm getting 3 sine of 35 degrees over 5 equals sine of B. And now, to find B, we are going to have to use inverse sine and our calculator. So to save yourself writing, I usually don't rewrite this. So it would be B equals inverse sine of that whole thing. And that's what we're going to type into the calculator. Okay, so we're going to do inverse sine of 3 times sine of 35. Notice you have to close the parenthesis after the 35, otherwise things will get messed up. Divided by 5, and then close the parenthesis once again, hit enter, and I'm getting 20.1 as my angle. So that's 20.1 degrees that we are getting. But remember, there are actually 2 possible angles between 0 and 180 degrees, and the calculator is only giving us 1. So let's find the other one, which would be found by doing 180 minus 20.1, and that would give you 159.9 degrees. And so the question you want to ask yourself is this angle possible for angle B? Is that reasonable? Can that work? And the answer is no here, because measure of angle A is 35 degrees. And this is about 160, and 160 plus 35 is too big for a triangle, right? Those are going to add up to more than 180 degrees, so that is not possible. Okay, so this, not possible because angles in triangle will add to more than 180 degrees, which means this is the only possibility for B, so we can ignore that one, put 20.1 here, and now we can continue to solve for C just like we did in the last lesson. Okay, so if this one had been okay, that would be a situation where you have two possible triangles and then you need to solve for both, which we will do in the next example. So step 2, now you're going to find measure of angle C by using the fact that these should add up to 180. So you're going to do 180 minus 35 plus 20.1, and you're going to get 124.9. And then you can find side C using law of sines once again. So sine of 35 degrees over 5 equals sine of 124.9 degrees over C. And do that, and you'll end up getting this over sine of 35 degrees. I'm doing this fast because we've done it already last week. And when you type that into the calculator, you're going to get approximately 7.15. Remember, the biggest angle should be across from the biggest side, so double check that just as a quick check to see if there are any mistakes, and this one looks good to go. So we're going to move on to another example, and this is an example that will result in two solutions, so two possible triangles. And in general, I am not going to tell you when there's 1, 2, or no solutions. That's just written for the sake of the notes. Okay, so you have to figure out which one it is. So I am going to start, maybe I'll skip the drawing this time since we already know which case we're in. So I have A is 6, 15 degrees, and B is 10. So again, we're going to start by finding B using law of sines. So step 1, find measure of angle B. So same steps as our last problem. And depending on how comfortable you feel with these steps, you could even go straight from writing this one to writing this one. Okay, so we're gonna plug that whole thing into the calculator and see what we get. So I'm gonna get inverse sine of 10 times sine of 15 divided by 6. So I am getting 25.55. Generally with angles, I'm going to say round to the nearest tenth, so I would round this to 25.6 degrees. So but remember, that's only one of the two possible solutions. So for this one, you're going to do 180 minus that. 180 minus 25.6 to see what you get, and you get 154.4. And then you think, okay, will this angle work with the given angle of 15 degrees? So if I add these two together, does that add up to more than 180 degrees? And here the answer is no, it does work out. So here we have two different solutions. One of the solutions will have measure of angle B as 25.6 degrees. The other solution, let's go ahead and fill in the whole thing, will have measure of angle B equal 154.4 degrees. And then you just need to find angle C and side C for both. So now you have to do the steps for both. So solution 1 and solution 2. So find this angle first. So 15 plus 25.6. So here I'm getting 139.4. So you're going to do that in both situations. Then find side C. Also, you need to do that in both of these. So, okay, we'll do all of solution 1, then we'll move to solution 2. So to find side C, same process. Oops, what am I doing? Over 6 equals sine, this pen is not working too well, over sine of 139.4 degrees over C. And so we'll end up getting C equals 6 sine, oh my goodness, 6 sine of, let me put a paper under here, sine of 139.4 over sine of 5, oh, sorry guys. This is a pretty, look, my pen is full of ink and it's not working. And then when you plug that into the calculator, let's see what we get. We're gonna get 6 sine of 139.4 divided by sine of 15. Enter, and I'm getting 15.08. So we could either write 15.09, I guess, or we could just round that to 15.1. So notice here, side C is the longest side because this is the biggest angle, but here we're going to have a small angle C. So after you do that, you're going to do the same steps for solution 2, find the angle C, and see what you get. So 15 plus 154.4. So I'm getting 10.6 for this one. Again, we're getting that because these should add up to 180. So here in this one, side C is going to be the smallest side. Okay. So now do the same steps all over again. So this type of work is quite repetitive. I'm going to type that in. And I am getting 4.26, which I will round to 4.3. You could round to the nearest tenth or hundredth. I'm not going to be too picky about that. So there you have it, 2 different solutions. I'll try to find a good video that gives a visual of like how these 2 solutions are possible in case you're interested. I will post it in modules. if I can find a good one. Okay, and our last situation is the no solution situation. So let's see how that ends up working out. So we're going to start with the same steps. You could definitely draw the triangle if you wanted to. We're going to first find measure of angle B. So same starting steps. So we have sine of 50 degrees over 5 equals sine of B over 8. And then we get, we end up getting that. And so we would get B equals inverse sine of that whole thing. So when I type this in, I want to see what happens. Inverse sine of 8 sine of 50 divided by 5. And I'm getting a domain error. So whenever this happens, you guys, I highly recommend checking if it makes sense that you're getting that, because sometimes you'll get this just because you got a typo when you were typing it in. So to be clear, first of all, the answer here is not domain error. That's what people like to write down. Sometimes that is not the answer. So let's go back and see if this makes sense. When it says error domain, that means that this is not between -1 and 1. So what I'm going to do is I'm going to go back and I'm just going to check what is that equal to. 8 sine of 50 divided by 5. It's bigger than 1, it's 1.22, so that's not possible. So it makes sense that we're getting a domain error. So here, your answer would be no solution. Again, that's because this is bigger than 1, or if it was less than -1. So always check, because you might have just gotten a domain error because you had a typo and not because there was actually no solution. Okay, so that problem, that's not possible. This would not form a triangle. It's impossible for it to form a triangle with those lengths and angles. So that's that. If you have questions, I will be available on Zoom throughout the week, and you can always email me. So the homework is posted in modules, and good luck with it, and I'll talk to you soon. Bye.